Digestive Physiology PowerPoint number 8. We've been looking at the small intestine. Now we have to look at the actual digestion and absorption of the small intestine. Let's start with carbs. Salivary amylase stops working in the stomach. Remember, that was secreted in the mouth and works in the mouth. It stops working when it's the stomach because the pH is too low because of the hydrochloric acid. 50% of dietary starch is digested before it reaches the small intestine. So your mouth and your stomach together take care of about half of the total job of breaking down carbs. Pancreatic amylase completes the first step in 10 minutes. Remember, that's secreted through the major duodenal papilla and minor duodenal papillae into the small intestine. That's going to break down polysaccharides, starches. Remember, a starch is a big string of beads where each bead is a simple sugar. So pancreatic amylase basically chops up that string of beads into smaller sugars, right? Then, once we get into smaller sugars, as the contents swirl through, look in that picture, you can see the circular folds, the plicae circulares on the small intestine. Those are covered with villi, and if you look closely, you can see the little villi on there. Then the microvilli, which are microscopic, form the brush border. You don't see those in the picture. They're not showing those. They have enzymes that are in-place enzymes. They don't float around. They stay on the microvilli. So as the contents swirl through the intestine, they come into contact with the brush border enzymes that break the little tiny sugars into individual sugars, like maltose, sucrose, lactose, and fructose. Even some of those are still disaccharides, but they're getting very small now, so where we can actually absorb them. Lactose, by the way, is indigestible after age 4 in most humans. That's because we stop producing lactase, which is the enzyme that breaks down the sugar lactose. So you hear people say, oh, I'm lactose intolerant. Yeah, we all are. Milk is for little kids. It's for babies. It's not for adults. You're not supposed to be drinking milk. Nature says no. That's why it cuts out your lactase. Remember, mammary glands are modified sweat glands, apocrine sweat glands. So when you drink a big cold glass of milk, you're drinking a big cold glass of modified cow sweat. And if you can't digest it, it's your fault. You know, there's actually genetic differences. Some of those people up in like Wisconsin and the cheese states, you know, they actually still have relatively high levels of lactase, so they can deal with it, but a lot of other people can't. Green Bay Packers fans, cheese heads, cheese boobs, oh my God. Actually, she looks like she has pretty decent abs. So how do the carbohydrates get in? This is a big deal. It's a sodium glucose transporter. This is going to come back over and over again. It comes back when we hit the kidneys. You know, this is one of those things I'm emphasizing. I'm saying it's a big deal. So what goes on here? Well, it's sodium glucose transporter, the SGLT, is a symporter. That means it transports two things in the same direction. It transports a sodium and a glucose, or a sodium and a galactose, simultaneously in the same direction. So look in the diagram in the upper left. The lumen of the small intestine, that's where all the current digested material is, all right, the stuff that we're trying to digest. And we have there, right there in the epithelial cell of the intestine, a pump, and it pumps sodium and glucose, or sodium and galactose, simultaneously inside. Why sodium? Because remember, sodium is the main cation of the ECF. And so there's this huge concentration gradient trying to get sodium to go inside the cell. So what the hell? Take advantage of it. Get a glucose and a galactose to hitch a ride, all right? So that's a big deal. That's how they get in. Fructose comes in by facilitated diffusion, then it's converted to glucose. As we'll see, all sugars are eventually converted to glucose in your body. Proteins then. So proteins are big strings of beads where every bead is an amino acid. All right. So pepsin, remember from the stomach, it has an optimal pH of 1.5 to 3.5. Well, in the small intestine, we're now at a pH of like 7.5 to 8. So it's not going to work anymore. What do we need instead? those pancreatic enzymes. The pancreatic proteases, they break down proteins. They will take big proteins, break them down into smaller polypeptides, then into even smaller oligopeptides. Oligo, root word, means a few. So that we get down to where we've got, just 3 or 4 beads left strung together of amino acids. Then when they hit the brush border breaks them down into individual amino acids. All right, see, same idea we saw before. Take a big giant string of beads, chop it up into many smaller strings, and then bit by bit keep chopping until we get down to individual beads. Okay, once again, amino acid co-transporters are what's going to move the amino acids in, along with some facilitated diffusion. Same idea as before. So we figured out how to deal with carbs and proteins. What about fats? They're a little more complicated because remember, they're not water soluble. They can't be absorbed directly into the blood. Difficult to digest because they are hydrophobic. They don't like water. So what happens is, in the duodenum, bile emulsifies fats. Remember, that's not digestion. Lipases digest fats. Bile simply breaks big chunks of fat down into smaller chunks of fat. Then the fats are digested by lipases. Lingual lipase from the salivary glands, remember, that was activated in the stomach, secreted in the mouth, activated in the stomach. But once we hit the duodenum, the pH is way too high. It doesn't work anymore. Pancreatic lipase has to take over. Lipases break triglycerides up into 2 free fatty acids, FFAs. That's not the future farmers of America. Most little kids in Nebraska belong to that, but not me. I had authority issues, just didn't work. And a monoglyceride. So on the right-hand side, see a triglyceride? It's a glycerol head with 3 fatty acid tails. Lipases peel off those outside 2 fatty acids and leave a monoglyceride behind. Okay, so we've broken down the fats. Now what? Now we have to absorb them. So what happens here is that the bile creates what are called micelles. Amphipathic bile acids. What a wonderful word that is, amphipathic. Amphipathic means a molecule that's hydrophilic on one end and hydrophobic on the other. Soap works that way. So what happens here is that you have these amphipathic bile acids. The hydrophobic side faces in, hydrophilic faces out. So this is the perfect solution. The hydrophobic side is happy to face water, and so it will actually dissolve in water. But the hydrophobic tails can transport fat. So it's like a special bus that can travel through the water, keeping the fats inside. Micelles absorb cholesterol, free fatty acids, monoglycerides, fat-soluble vitamins, which again are A, D, E, and K. All those are packaged into the micelle. Free fatty acids and monoglycerides are resynthesized into triglycerides in the smooth endoplasmic reticulum of intestinal cells. So when you ate food, when you ate plants and animals, there were fats, but they're not exactly the fats that your body needs. So your body first breaks them down with the lipases, then right here in the smooth endoplasmic reticulum of the intestinal cells, your body repackages those raw materials into the very triglycerides that you need. Is that the cat's ass in the moonlight or what? So then the Golgi complex puts them into lipoproteins called chylomicrons. Remember, we talked about lipoproteins the first couple weeks of the semester. VLDL, IDL, LDL, HDL. That's what people incorrectly call cholesterol, all right? But in fact, it's a lipoprotein, and it transports fats. Look at the chylomicron. It is the granddaddy of lipoproteins. It's huge, so it can carry a lot of fat. And so chylomicrons are then absorbed into the lacteals, right, in the villi, and they form the basis of chyle, the milky white lymph that then is eventually, it travels through the lymphatic vessels and is dumped into the subclavian veins, where it's now safe to travel because inside of those chylomicrons, they are soluble in water, even though they carry all those fats inside. Here is a fantastic slide showing a summary of all that absorption. So look up at the top. Glucose and galactose coming in via those SGLTs, also fructose by facilitated diffusion. Amino acids also coming in through co-transporters. Little oligopeptides can get through. Microvilli breaks them down into individual amino acids. Short chain fatty acids, if they're small enough, they'll diffuse right through the membrane, of course, because we already knew that. But they can also travel just fine in a hydrophilic environment. It's the long chain fatty acids. The lipases had to break them down into monoglycerides and some free fatty acids. They come through by simple diffusion, and then in the epithelial cell, they're repackaged into triglycerides, reformed, reconstituted into triglycerides that we need, put into chylomicrons, then absorbed in the lacteal, eventually returned to the bloodstream. Another simple slide summary. Notice how you can see the chylomicrons are being taken up by the lacteal, whereas the amino acids and the monosaccharides and those little short chain fatty acids, they can go ahead and come right into the blood. So having dealt with the big macromolecules, there are just a few other little things left over. So nucleic acids, actually one of the macromolecules, but they're so simple, they're easy to deal with. The nucleases, the pancreatic deoxyribonucleases and ribonucleases, break down DNA and RNA into nucleotides, and then other enzymes in the brush border split them into simple phosphate ions and simple sugars, very easy to deal with. Vitamins come through unchanged. A, D, E, and K come in with lipids into the lacteals. B and C are water soluble. They can go right into the blood. B12 bound to intrinsic factor. That's how it gets in. Minerals all along the small intestine. Sodium co-transported with sugars and amino acids. Remember those SGLTs. And chloride exchanged for bicarbonate. It's the chloride shift again, all right? That comes up again and again in physiology. Iron and calcium, we just absorb those all over the place whenever we need them, okay? Easy peasy. So the last thing to consider here is that the small intestine has to get back to water. Let's see what happens here. Your digestive tract gets about 9 liters of water a day. That'd be like, liters, a little more than a quart, it's like 10 quarts of Gatorade. All right? Now, 0.7 of that comes in through your food, things like apples and oranges and huge amounts of water in the food. 1.6 liters through drink, but look, 6.7 are in those secretions. All those secretions in the stomach and in the pancreas, the small intestine, all those secretions are in large part water. So that's where most of the water in your digestive tract comes from. Now you have to reabsorb it. 8 liters absorbed in the small intestine, 0.8 in the large intestine. So we have to get that water back. It's too valuable to let it leave, so we try to bring it back in. Water absorbed by osmosis. It's the same thing we've seen before. Water follows solutes. Those transporters, when they're transporting sodium and glucose and amino acids, well, the water comes right along with it. That's how we get the water back. Diarrhea is when you absorb too little of that water. So when you eat that piece of pizza that sat on the counter all night, it's covered with nasty ass stuff, gets down into your small intestine goes, oh my God, this is so nasty. And it says, this needs to leave now, and therefore there's not enough time to reabsorb the water, and that's what diarrhea is. It's just basically your small intestine saying, get the hell out of here, and it lets it right through. Feces pass through too quickly if the intestine isn't irritated. Feces contain high concentrations of solute, that's another reason. So all the lactose intolerant stuff. Yeah, lactose in milk. Most people don't have hardly any lactase after age 4, so you can't digest it. And your small intestine said, why is this here? Get rid of it now. And constipation is just the opposite. That's where you can't absorb enough water, so the feces is hard, and people have trouble expelling it. Commas, use them. Persistent cough, EMS post-op left shoulder, unable to eat, diarrhea. Yeah. And assuming I survive this, this is where I'm going. This is Kanab Point, Grand Canyon. There's the moon coming up. It's a 60-mile four-wheel drive road to get here, and it doesn't really show up on maps, and GPS doesn't really work. You actually need maps and a compass. And here at the end of the day, I just sit, drink tequila, play my guitar, and just feel happy to be alive and alone.